no music versus low volume. Take a moment to follow along with me here to make sure you can line these up in the table. No music versus low volume had a P of 0.963. So that's none versus low, P 0.963. And then no music versus high volume, none versus high, had a P of 0.027. You can see that right here. And then low volume versus high volume, this result right here, low versus high, had a P of 0.049, and you can see that right here. Okay, and we found that this first test was not significant, and the latter two tests were significant. So no music versus high, low volume versus high volume. So if we look at these means here, I have the means presented here, and they were obtained by going to the descriptives table. So notice these here, 84.9, 84.2, and 77.5. These are just displayed once again here. You see the three matched up. Okay, so I have the means here to make this a little bit easier. And for the significant results, what I want to do is see which group had the better exam performance. So for no music versus high volume, notice the no music mean is 84.9, while the high volume mean is 77.5. So this indicates, since it was significant, this indicates that no music performs significantly better than the high volume. So I'm going to write this here. No volume, no was greater than high. Just shorthand it there. And then low volume versus high volume was also significant. This was very close, but it was in fact significant. So let's compare these two means. Low is 84.2 and high is 77.5. So we can see here that the low volume group performs significantly better than the high volume group. So we'll write that here. Low greater than high, just shorthanding our results. And then once again, no music versus low volume was not significant. So we could summarize the results at this point. These are all our tests. There was not a significant difference between no music and low volume. And then we could say that the no music condition and the low volume condition, these were both significantly higher than the high volume condition. Now let's take a moment to look at our final table, the homogeneous subsets table. And the way to interpret this table is as follows. Groups that share the same column are not significantly different. So if groups share a column, there's no difference. And groups that do not share the same column are significantly different. So let's take a look at that in our table here. Let's start with the groups that share a column. Notice here in column 2, we have low volume and we have none or no music, no volume. These two groups share column 2. So that means that since they share the same column, they are not significantly different. So we would say low and no volume are not significantly different. However, once again, groups that do not share the same column are significantly different. So notice that the high volume group is in its own column. It doesn't share the same column with low and none, which is right here. So this indicates, since they don't share the same column, this indicates that low volume and none are in fact significantly different than high. And the nice thing about this table is, not only is it not redundant, as was the multiple comparisons table, where it presented every result twice, but it also has the means inside the table. So I know that low and none are significantly different than high. But I can actually see the means here as well. So when I know there's a difference, all I have to do is look at the means and see which ones are higher. So I can see that low volume and none are in fact higher than high volume. So they're significantly higher in terms of exam scores than the high volume group. So I could summarize these results as follows. There was not a significant difference between the low volume and the no volume group. You see that right here. However, the low volume group and the no volume group were significantly higher than the high volume group. So once again, these two tables will give you the same results. They're just presented somewhat differently. Now, some post hoc tests are presented with this type of table, and then some are presented with this type of table as well. But some of the tests available under the post hoc button do not have this type of presentation at all. We're going to focus on Tukey's test because research indicates that it's a pretty good test and it still does a good job at keeping our alpha at 0.05 overall. This concludes the discussion of post hoc tests for the Way ANOVA. Thanks for watching.